Hi everyone. Today we are going to learn the chapter 2 matrices. Our learning standard is to represent information from real situations in the form of matrices. So what is matrix? A matrix is a set of numbers arranged in rows and columns to form a rectangular or a square array. So for your information, a matrix is usually represented with capital letter and written in the bracket. So always make sure that when we write down the matrix, it must have the bracket. So let's look at this example. Okay. The table shown the data for the selling of the fan in the month of March. So we can transfer them into the matrix form. Okay, transfer them into the matrix form. So make sure we have the bracket. So we have the rows. Rows means the horizontal number. So we have 2 rows here. The vertical number, we call them as column. So we have 1 column, 2 column, 3 column. So this is what we call as matrix. Yeah, look at this example. This is another example. Okay, so we can put them into the matrix by writing down the bracket. So since it is only 1 row, we call them as row matrix. And if we write them in the vertical form, we call them as column matrix because it has only 1 column. So row matrix, 1 row only. Column matrix, 1 column only. Next, okay, so it's very simple. We just transfer them into the bracket. So in this example, we have 3 rows, row 1, row 2, row 3, and also 3 columns, column 1, column 2, and column 3. So we call this as square matrices because a square matrices has the same number of rows and columns. Okay, another one. In test 1, Samad scores 76 marks for Bahasa Melayu, 82 marks for mathematics, and 72 marks for history, while Hamid scored 80 marks for Bahasa Melayu, 88 marks for mathematics, and 70 marks for history. So we can put all the data into a bracket and it is in matrix form. So we call this as rectangular matrices because they have different number of rows and columns. So in this example, we have 3 rows, but only 2 columns. Okay, in this one, we have 2 rows and 3 columns. Okay, so after this, you can try the exercise self-practice 2.1a. Try to transfer them into the form of matrix. Okay, so next, our learning standard is to determine the order of a matrix. Hence, identify certain elements in a matrix. So how to determine the order of a matrix? Okay, order of a matrix can be determined by counting the number of rows followed by the number of columns of the matrix. Okay, for example, row 1, row 2. This matrix has 2 rows. Column 1, column 2, column 3. This matrix has 3 columns. Therefore, it is a matrix with order 2 times 3. But we are not reading it as times. We read it as matrix 2 by 3. 2 by 3. So matrix with m rows and n columns has the order m times n and is read as matrix m by n. M by n. So every number in the matrix is known as an element of the matrix. For example, the element at the second row and third column. Second row and third column. Okay, let's see. Just now we have the row 1 and row 2. So second row means second one. Third column, so we have the first column, second column, and third column. Okay, so we found that second row, third column. Okay, we spot the 4 here. So the element at the second row and third column will be 4. Capital letter is used to denote a matrix. For example, A equals to 16, 18, 11, 5, 10, 4. And the element at the second row and third column can be represented as A, 2, 3. So we use the capital letter for a matrix, a small letter to present an element. So the 2 and 3 here represent the row and the column. So element at second row and third column is 4. In general, the element at the I row and j column in matrix can be represented as Aij. So I represent row, j represent the column. So A is a matrix. A11, A12, A11 means row 1, column 1. A22, second row, second column. Okay, so let's look at this example. And we have 3 matrices here, P, Q, and R. Determine the order of each matrix and the element at the first row and third column of matrix P, second row and first column of matrix Q, third row and fourth column of matrix R. So remember how to determine the order of a matrix? It is row by column, row by column. So P, how many row? 1 row. How many column? 1, 2, 3. So the order of matrix P is 1 by 3. Q, 1 row, 2 row, 1 column. So it is 2 by 1. 2 by 1. Okay. R, 1, 2, 3, 4. 4 row. 1, 2, 3, 4. 4 column. So the order of matrix R is 4 by 4. 4 by 4. The element at the first row and third column of matrix P. First row, third column. So column 1, column 2, column 3. So the element is 9. Okay. Second row and first column of matrix Q. Second row and first column. So our element is 5. Third row, 1, 2, 3. Fourth column, 1, 2, 3, 4. So find the intercept between the row and the column. So our element is 1. Okay. So try your self-practice 2.1b after you have go through the example just now. Okay, so the third learning standard is determine whether two matrices are equal. How to determine whether two matrices are equal? Let's look at the two matrices below. It is found that matrix M and matrix N have the same order, which is 2 by 2. And if each corresponding element is equal, which is A equals to 1, B equals to 2, C equals to 3, and D equals to 4, then matrix M and matrix N are equal and can be written as M equals to N. So we have two qualifications here. To make sure two matrices are equal, first, we have to make sure that they have the same order. Same order means they have the same number of rows and same number of columns. And they must have same corresponding element. Same corresponding element. So, look at this example. Determine whether each of the following pairs of matrices is equal. Give your reason. Okay, now we look at A and B. First, we have to make sure their order. So what is the order for our A? 1 row, 2 row, 1 column, 2 column. So 2 by 2. 2 row, 2 column. Okay. Look at B now. 1, 2. So 2 row, 1, 2. 2 column. So also 2 row, 2 column. So we can say that the order of A and B are the same. Now let's compare the corresponding element. Okay, 2, 2, 11, 11, 1, 1, 3, 3. They have the same corresponding element. So A equals to B because both the matrices have the same order and each corresponding element is equal. B, 1 row, 1 column, 2 column. So 1 row, 2 column. Let's look at D. 1 row, 2 row, 1 column. So this is 1 by 2, but D is 2 by 1. So since they have the different order, then they are not the same. They are not the same. So they are not equal matrix. See? 2 by 2. F 2 by 2. 8, 8. 3, negative 7. Okay. They have the same order, but unfortunately, they don't have the same corresponding element. So they are not the equal matrix. Okay, last one, G and H. 3 row, 2 column. 3 row, 2 column. 0.5, 1 over 2. 0.5 equals to 1 over 2. Negative 2, negative 2. 6, 6. 0.8, 4 over 5 also equals to 0.8. Negative 1, negative 1. 12, 12. So since they have the same order and same corresponding element, then we say they are equal matrix. Okay? So since they are equal, we can use them to solve the problems. Okay, let's look at example 5. It is given that matrix P equals to X, 7, 0, 5 minus 3Z. And matrix Q equals to 5, Y plus 1, 0, and 2Z. Determine the values of x, y, and z if P equals to Q. So what is meant by P equals to Q? Remember, they have the same order and same corresponding element. So how to solve them? Remember, they have the same corresponding element. So x equals to the 5. 7 equals to the y plus 1. 0 equals to 0. 5 minus 3z equals to 2z. So we will write them out separately to solve the value for x, y, and z. So x equals to 5. So this one don't have to count. 7 equals to y plus 1. Remember, corresponding element. They are located at the same position. So bring the plus 1, 7 minus 1. So y equals to 6. Minus 3z, okay, we bring backward. 2 plus 3 becomes 5z. So z equals to 5 divided by 5, z equals to 1. Okay, so let's try your soft practice 2.1c about the equal matrices. Okay, so now we are going to learn about add and subtract matrices. So how to add and subtract matrices means we are going to plus or minus the matrix. So addition and subtraction of matrices can only be performed on the matrices with the same order. Remember, to do the addition or subtraction, the matrices must be of the same order first. Each corresponding element is added or subtracted to obtain a single matrix with the same order. For matrix A, okay, so remember, the small letter represent the element. The first number represent the row. The second number represent the column. So A11 means element at the first row and first column. A12, A21, A22. Matrix B, B11, B12, B21, B22. So for addition or subtraction, we need to add or subtract each corresponding element. So A11 plus B11, A12 plus B12, A21, B21, A22, B22. Okay, so this is plus. Subtract, do the same thing, but we use the symbol of the minus. Okay, so look at this example. Determine whether addition and subtraction can be performed on the following pairs of matrices. A, B. So, are they of the same order? A, 2 row, 3 column. But B is 2 row, 2 column. So the addition and subtraction cannot be performed because they have different orders. B, 1 row, 2 column. 1 row, 2 column. Yes, they have the same order. So the addition and subtraction can be performed. Next, E, F, 2 row, 2 column. 2 row, 2 column. Yes, same order can be added or subtracted. D, 2 row, 1 column. 2 row, 2 column. Cannot be added or subtracted because they have different orders. Okay. Now we have matrix C, matrix D, matrix P, and matrix Q. So we have C, D, PQ. We have 4 matrices here. So calculate C plus D, P minus Q. So remember, if we want to do addition or subtraction, they must have the same order. So C is 2 row, 3 column. D is also 2 row, 3 column. So we can add them together. P, 3 row, 3 column. Q also 3 row, 3 column. So they can do the subtraction. Okay. So C plus D, what are we going to do is put all the corresponding element together using the addition. So solve to get our answer. P minus Q, this is P, this is Q, same order, so put the minus. Okay, so P11 minus Q11. P12 minus Q12. P13 minus Q13. So after we put them according to the corresponding elements, so press calculator to get our final answer. So it's very simple. Okay, now example 8. Given that matrix D, matrix E, and D plus E equals to 8, -1, -5, and 13. So this is advanced level. Solve the problems given. You need to calculate the values of X and Y. So since it is given D plus E equals to 8, -1, -5, and 13. So we will put D and E together by using the symbol plus. So put all the elements of matrix D, matrix E. Okay, so put the addition according to their corresponding elements. So we will solve them. Okay, solve them. 3x minus 1 equals to 8. So bring it out. 3x minus 1 equals to 8. 3x equals to 9. So x equals to 3. Okay, and then 5 plus 2y equals to 13. So 2y equals to 13 minus 5 equals to 8. Y equals to 4. Okay, y equals to 4. So we can solve the problems when we know that the two matrices are equal matrix. Yeah, so we can find the value for the unknown x and y given here. Example 9. Given that f plus 16, -3, minus 7, 10 equals to -2 and 3. So calculate matrix F. So 16 minus 7, -3 minus 10. Yeah, you can bring this to the back. So positive becomes negative, negative becomes positive. So join them. -2 minus 16 plus 7. 3 minus -3 plus 10. So F equals to -11 and 16. Okay. Okay, example 10. Calculate the closing stock of each type of textbook. So how to calculate our closing stock? Opening stock plus new books received minus lost and damaged books. So we will get our answer for the closing stock of science, mathematics, and economy textbooks. Okay, so now try the self-practice. Okay, Try the soft practice. Okay, so this is the last part in this video. That is how to multiply a matrix by a number. How to multiply a matrix by a number. Okay. Multiplication of a matrix by a number is the process of repeated addition of the matrix. If matrix A is multiplied by a number n, then matrix A can be added to the same matrix A repeatedly for n times. Okay, so n is the number, just like 3 times 2. 3 times 2 means 2 plus 2 plus 2. Okay, n means the number, how many times it is repeated. So this formula means that each element in matrix A is added to the same element repeatedly for n times. Therefore, to multiply a matrix by a number, multiply every element in the matrix with the number. Okay, so A is the matrix, n is the number. So NA equals to n, ABCD is the element. So we will multiply the n into the bracket to each of the A, B, C, and D. So it is NA, NB, NC, ND. So multiplication of a matrix by a number is known as scalar multiplication. Okay, let's look at example. D, -5, 4, 2, 1. Calculate 3D. 3D. So 3 means D repeated for 3 times. D repeated for 3 times. So what are we going to do? Put the 3 in front of the matrix D. So after that, multiply. Multiply 3 into the bracket. So 3, -5, 3 times 4, 3 times 2, and 3 times 1. So all the elements must be multiplied by 3. Then we get our answer. Okay, -1/2D. Okay, put the -1/2 in front of the matrix D and then multiply them into the bracket 1 by 1 to every element. So we get our answer here. So the result here shows that A plus B equals to B plus A. Addition of matrices obeys the commutative law. But A minus B cannot equals to B minus A. So subtraction of matrices does not obey the commutative law. Okay, H A plus B. Okay, if there is a repeated times for A plus B, so it will be HA plus HB. HA minus B will be HA minus HB. So addition and subtraction of matrices obey the distributive law. A plus B plus C equals to A plus B plus C. Okay, so you see the difference for the bracket. So it means we plus A and B first. Only that we add in C. Okay, in this situation, we will add B plus C first. After that, we add with A. Okay, but we still get the same answer. So addition of matrices obey the associative law. However, A minus B minus C not equals to A minus B minus C. Okay, you see the bracket, A minus B in the bracket. This is B minus C in the bracket. So subtraction of matrices does not obey the associative law. A matrix with all its elements equal to 0 is called zero matrix. For example, 0, 0, 0, 0. So addition and subtraction of matrix A with the zero matrix are A plus 0 matrix, we still get back A, matrix A. And A minus 0 matrix, we still get back matrix A. Okay, next example, P and Q. Calculate 3P minus Q. Okay, remember P minus Q is in the bracket, so you have to solve the bracket first. So 3, this is matrix P, matrix Q. So this is in the bracket, in the bracket. So solve them first. 7 minus 2, 9 minus negative 3, negative 3 minus 1, 8 minus 5, 6 minus 0, 12 minus 4. So after we get an answer, we multiply the 3 into each element. So this is our final answer. Okay. Example 13. This is scalar multiplication. 1 over 2 times 4 and 12. So multiply them into the bracket. So we get a 2 and 6 minus x and negative 3 equals to 5y. So join them. 2 minus x, 6 minus negative 3. So 2 minus x equals to 5. X equals to 2 minus 5. X equals to negative 3. 6 minus negative 3 equals to y. 6 minus negative becomes positive. Y equals to 9. Okay, then 4r plus 9, 0, 2, negative 3 equals to negative 3, 4, 10, and 1. So bring the matrix, positive becomes negative. So we get this answer. Okay. To bring this 4, so we will multiply them with 1 over 4. Multiply them with 1 over 4. So since we multiply 1 over 4 here, we also multiply 1 over 4 here. So multiply the 1 over 4 into each element. Then we get our final answer, negative 3, 1, 2, and 1. Okay. Calculate the number of vehicles parked at the parking area in a week. So this is average number of vehicles per day in a parking area for 5 working days, represented in table X. Table Y represents the average number of vehicles per day on weekends. So this is working day. This is weekends. So we have 5 working days and we have 2 days of weekend. So every day we have these numbers. So we have 5 working days, put the 5. We have 2 weekends, so put the 2 here. Okay, so multiply 5 into everyone in the bracket. Multiply 2 into everyone in the bracket. And finally, put them together to get the final answer. Okay, so solve practice 2.2b. Please try to solve it. Okay, so that's all for today. Thank you.